Today, we can discuss the concept of the Cobb-Douglas production function. Before explaining this Cobb-Douglas production function, we should know what the production function implies. That is, the production function shows the functional relationship between factor inputs and output. The production function represents the relationship between factor inputs and output, and it explains how this factor inputs can be used to produce a particular level of output. How this factor inputs can be used to produce a particular level of output. So such a formulation of this one, that is such a specification, especially the relationship between factor inputs and output, was developed by two economists and statisticians like Charles Cobb and Paul Douglas. Charles Cobb and Paul Douglas developed their own production function to specify the functional relationship between factor inputs and output. A more or less similar version was developed by another economist like Knut Wicksell. That is, a similar version of this Cobb-Douglas production function was developed by Knut Wicksell, but the most important and the more specification was done by this Charles Cobb and Paul Douglas through their own production function. And this production function is in the form of Q is equal to A L raised to alpha and K raised to beta. That is Cobb-Douglas production function, otherwise known as CD function. And as per the production function, that is the level of output Q is equal to A L raised to alpha K raised to beta. Q is equal to A L raised to alpha and K raised to beta, and here Q is the level of output. Q is the level of output and A is the technological parameter and which is assumed to be constant throughout the production function. A is the technological parameter and that technological parameter is assumed to be constant. And the next factor is L is equal to the amount of labor force used for producing the level of output Q, and K is the amount of capital for producing that particular level of output, and alpha represents the output elasticity of labor. Output elasticity of by keeping capital as constant. And this output elasticity of labor represents at what extent the level of output is increased by using a single unit of labor force extra. That is, an additional labor force contribute something to the total output, and that changed output associated with the change in labor force represented here as alpha, and this alpha represents thereby output elasticity of labor by keeping capital as constant. And here we are not considering the output elasticity of capital, that is what actually produced by capital is not taking into our consideration. Rather, we are taking alpha as the labor's contribution, that is an additional labor's contributions to the total level of output, and beta is the output elasticity of capital. By keeping labor as constant. That is an additional capital contributes something to the total output. Thereby, this beta represents the changed output, that at what extent the output changed with respect to the change in capital. So this is the major components belonging to that particular production function, that is Q is equal to A L raised to alpha and K raised to beta. And here, before explaining the properties of this Cobb-Douglas production function, there is an assumption related to the same. There is an assumption, only then this Cobb-Douglas production function satisfy the following properties. That is, the assumption is that a strict Cobb-Douglas production function is in the form of, that is alpha plus beta is equal to 1. A strict Cobb-Douglas production function must satisfy this condition, that is alpha plus beta is equal to 1, which represents the constant returns to scale. And which implies that there is a proportionate change in factor inputs leads to a proportionate change in output. That is, a proportionate change in factor inputs leads to a proportionate change in output. Then thereby we can say that that is a situation of this constant returns to scale. Alpha plus beta is equal to 1 because here alpha represents the output elasticity of labor and beta represents the output elasticity of capital. And if you are summarizing or if you are summing up of this output elasticity of labor and capital, we will get an answer like 1, and which means that there is a constant returns to scale. CRS assumption is the in the case of this Cobb-Douglas production function. And we can move towards the topic of the properties of this Cobb-Douglas production function, especially the mathematical properties of this Cobb-Douglas production function. The mathematical properties of this Cobb-Douglas production function. And for the purpose of explaining the same, we can use the tool like the differentiation process. We can use the tool like the differentiation process in order to satisfy the mathematical properties of this Cobb-Douglas production function. And first one, that is the first property of this Cobb-Douglas production function, is that it is a linearly homogeneous of production it is a linearly homogeneous production function of degree 1. It is a linear homogeneous production function. It is a linear homogeneous production function of degree 1. It is a linear homogeneous production function of degree 1. And here, that is a linear homogeneous production function implies the production function is a linear one. The production function, that is Cobb-Douglas production function, is a linear one. And here that is Q is equal to A L raised to alpha K raised to beta is a linear production function, which means that there is a perfect relationship between, or a perfect correlation between factor inputs and output. That linear relationship shows that there is a perfect linear relationship between these factors of production and the total output. That is, if the factors of production is doubled, then the total outputs too is also doubled. Thereby, we can say that there is a perfect linear relationship between this factor inputs and output. And the second one is that here this linear is satisfied, and the second one is that it's a homogeneous production function. It's a homogeneous production function, which means that if the factors of production is multiplied by a particular real constant, that is, if the factors of production is multiplied by a real or particular real constant, then the outputs too is also can be obtained in the form of that multiplication of that total output with the respective real constant. That is, if the factors of production is multiplied by a real constant, then the total outputs too can be multiplied by the same real constant. That is, a proportionate increase in the factors of production leads to a proportionate increase in total output. That's what the explanation provided in the form of this linear homogeneous production function. And here the production function is equal to Q is equal to A L raised to alpha and K raised to beta, and the changed output, that is the changed output associated with the multiplication of this real particular constant, that is, here we are taking lambda as that constant, and thereby the changed output, that is Q star, is equal to A, that is assumed to be constant, that is technological parameter, and lambda L raised to alpha, lambda K raised to beta. Lambda L raised to alpha and lambda K raised to beta, and here lambda is the real constant that we are used to multiply the factors of production in order to realize the impact made by this changed labor force and changed capital force on the level of output. And this can be rearranged like, that is again equal to A lambda raised to alpha, L raised to alpha, lambda raised to beta, and K raised to beta. Lambda raised to alpha, L raised to alpha, lambda raised to beta, and K raised to beta. And we can take the common factors outside, and thereby this is equal to lambda alpha plus beta A L raised to alpha K raised to beta. K raised to beta, lambda alpha plus lambda raised to alpha plus beta, AL raised to alpha, and K raised to beta. And the thing is that already we mentioned that is a strict Cobb-Douglas production function is like the form of alpha plus beta is equal to 1. Alpha plus beta is equal to 1. Thereby, this is again equal to lambda alpha plus beta means lambda raised to 1, A, L raised to alpha, and K raised to beta. And here, this AL raised to alpha and K raised to beta represents the level of output. And thereby, if the level of output is multiplied by lambda, will provide the changed level of output. that is lambda q is equal to the same, that is a changed level of output. That is the first property, and here the degree, lambda's degree is 1, thereby we can say is that it is a linear homogeneous production function of degree 1. Here the power of that real constant is 1, thereby we can say is that whose in the degree is in the form of 1, or the degree is 1, and at the same time this follow the principles like it's a linear production function, and at the same time it's a homogeneous production function. That is, if the production function is multiplied by a particular constant, thereby we can say is, or we can factor out that particular constant completely, and there is no remain in the form of that that lambda in our production function. Thereby we can say is that it's a linear homogeneous production function. And the second property is that the average product of this factors of production, can be obtained in the form of a ratio, and that ratio is like the ratio of the factor inputs. The average product can be obtained by the ratio of the respective factors of production. The average product can be obtained, the average product of each of these factors of production can be obtained by a ratio of the respective factors of production. And thereby, if you are taking this average product of labor, this is again equal to that is Q by L provide the average product of labor. Q by L provide the average product of labor. Thereby, this is A L raised to alpha K raised to beta divided by L. A L raised to alpha and K raised to beta divided by L provide the average product of labor. And this can be rearranged like this. That is A L raised to alpha K raised to beta divided by L raised to 1. L raised to 1. We can change this, that the power of L is 1, and thereby we can change the same, that is A K raised to beta, and we are taking this L raised to alpha as a denominator of this function, and thereby this is again equal to L raised to 1 minus alpha. Here the base is same, and the powers are 1 and alpha, and if you are taking this L raised to alpha as a denominator, this will become a negative sign. The lambda's values will become negative, thereby this is equal to L raised to 1 minus alpha. L raised to 1 minus alpha is equal to beta. L raised to beta, that is A K by K raised to beta divided by L raised to beta, and the beta are same, thereby this is again equal to A K by L the whole raised to beta. And here the value is obtained in the form of a ratio, that is a capital labor ratio, that is the respective factors of productions are associated or represented in that particular ratio also. Ratio. And the second is that the average product of capital can be obtained in the same way. The average product of capital is equal to the same, that is Q by the amount of capital, that is A L raised to alpha K raised to beta, and hereby divided by K. The power of K is 1. This is again equal to A L raised to alpha divided by K raised to 1 minus beta. K raised to 1 minus beta. This is again equal to A L raised to alpha divided by K raised to 1 minus beta, means 1 minus beta is alpha. Since alpha plus beta is equal to 1, 1 minus beta is equal to alpha. Thereby, this is again equal to K raised to alpha. And here the power of the labor and the capitals are same, that is alpha itself. Thereby, we can rearrange the same is like, that is A L by K the whole raised to alpha. A L by K the whole raised to alpha. This is also shown in a ratio, that is the respective factors of production. This is the second property of this Cobb-Douglas production function, that is average product of the factors of production can be obtained by a ratio, and that ratio is in the form of the respective factors of production, either K by L ratio or L by K ratio. This is the second property. And third property is a closely related concept of this average product of labor and average product of capital, that is the marginal product of labor and the marginal product of capital. The third property is that the marginal product of both the factors of production like labor and capital is also expressed in terms of the ratios of this factor inputs. The marginal product of the same factors of production, that is labor and capital, can also be expressed in terms of the ratios like the respective factors of production. And here the marginal product is associated with the marginal concepts, and marginal product of labor is required along with the marginal product of capital too. Marginal product of labor and marginal product of capital needs to be find out. And here, since we are dealing with the mathematical economics and the Cobb-Douglas production function associated with the marginal concept, we need to differentiate the production function. We need to differentiate the production function, that is Q is equal to L raised to alpha and K raised to beta. Since we are using two factors of production, labor and capital, we cannot use the total differentiation. Instead, we can use the partial differentiation. Instead, we can use the partial differentiation. Thereby, MPL is equal to dou Q by dou L. Dou Q by dou L. That is differentiating the production function with respect to the labor itself. And here, the production function is A L raised to alpha and K raised to beta. A L raised to alpha and K raised to beta. Dou Q by dou L. Dou Q by dou L of A L raised to alpha and K raised to beta is equal to A alpha L raised to alpha minus 1 K raised to beta. K raised to beta. That is A alpha L raised to alpha minus 1. Here we are differentiating only labor itself, not capital. And thereby the differentiated value of labor is equal to alpha labor raised to, that is alpha L raised to alpha minus 1 K raised to beta. And this can be rearranged like, that is A alpha K raised to beta the whole divided by L raised to 1 minus alpha. If you are taking this L raised to alpha minus 1 as a denominator, this will become like L raised to 1 minus alpha. And 1 minus alpha is beta. Thereby, this is again equal to A alpha K raised to beta divided by L raised to beta. And this is again equal to alpha times of A K raised to beta divided by L raised to beta is again equal to alpha times of A K by L the whole raised to beta. K by L the whole raised to beta. K by L the whole raised to beta. And here A K by L the whole raised to beta represents the average product of labor. Average product of labor as per the second property, and thereby the marginal product of labor is the alpha times of average product of labor. The marginal product of labor is the alpha times of average product of labor is the marginal product of labor. This is the third property's first component, that is alpha times of average product of labor will provide the marginal product of labor. And likewise, we can calculate or we can find out the marginal product of capitals too. We can find out the marginal product of capitals too by using the same principle, that is a partial differentiation. Instead of differentiating the function with respect to labor, we can use here as capital, that is dou Q by dou K. And here also dou Q by dou K represents A L raised to alpha beta K raised to beta minus 1. A L raised to alpha beta K raised to beta minus 1. Here we are differentiating the original production function with respect to capital itself, and thereby this will be equal to A L raised to alpha beta K raised to beta minus 1, and this beta can be taken in front of this function beta A L raised to alpha and this K raised to beta minus 1 can be taken as a denominator, and this will become K raised to 1 minus beta. K raised to 1 minus beta, and this is again equal to beta times of A into L raised to alpha divided by K raised to 1 minus beta. 1 minus beta means alpha. 1 minus beta is alpha. Thereby, this is again equal to K raised to alpha. K raised to alpha, and this is again equal to beta A L by K the whole raised to alpha. Beta A L by K the whole raised to alpha, and this portion represents the average product of capital from the second property, and thereby the marginal product of capital is equal to the beta times of average product of capital. Beta times of the average product of capital. This is the third property. And the fourth property is that the Cobb-Douglas production function satisfies the Euler's theorem. Cobb-Douglas production function satisfies the Euler's theorem or Euler's theorem. It satisfies the Euler's theorem or Euler's theorem, which says that If we are distributing the total output, on the basis of the factors of production and marginal productivity, if we are distributing the total product on the basis of the marginal productivity of the factors of production, then the total output will completely vanish off or exhausted. If the total output is distributed among the factors of production and that is based on their marginal productivity, then we can say that there is nothing as a remainder. Thus we can say is that Euler's theorem, that is the total output is distributed on the basis of their respective marginal productivity, then the total output will be exhausted or vanished off. And this can be written like this, that is amount of labor into the marginal product of labor is dou Q by dou L plus the amount of capital into dou Q by dou K represents the marginal product of capital. And this is equal to the level of output, that is the total output is distributed on the basis of their respective marginal productivity, and that will provide, that is the level of output, that is the total output will be completely exhausted. And here that is L into dou Q by dou L means A alpha L raised to alpha minus 1 K raised to beta into the amount of capital, that is K, into dou Q by dou K means A L raised to alpha beta K raised to beta minus 1 and here this alpha and beta can be taken outside and here the sign is plus, that is A alpha L raised to alpha minus 1 K raised to beta plus K into A L raised to alpha beta K raised to beta minus 1, and here alpha and beta can be taken outside, that is alpha plus beta into, that is AL raised to alpha and K raised to beta is the and we can split the functions differently. That is A, this L is appearing here as L raised to 1 and L raised to alpha minus 1 K raised to beta plus this again A, K is appeared here as K raised to 1, L raised to alpha, K raised to beta minus 1. And here L raised to 1 and this minus 1 can be cancelled, and here K raised to 1 and this minus 1 can be cancelled out. Thereby we can take this as A L raised to alpha and K raised to beta. Here A L raised to alpha and K raised to beta is taking place, plus here also A L raised to alpha and K raised to beta. And here also this value, that is alpha plus beta, is always there, that is here alpha is there and here beta is there, and thereby that is alpha and here beta, and suppose if you are removing the same, that is A alpha L raised to alpha K raised to beta plus A beta L raised to alpha K raised to beta, and here we are taking the original production function, that is A L raised to alpha and K raised to beta from both of this part, that is A L raised to alpha and K raised to beta is on both sides. Thereby we can take that A L raised to alpha and K raised to beta outside, and the remainder is alpha plus beta, and this alpha plus beta is equal to 1. Thereby this will become A L raised to alpha and K raised to beta into 1. This is again equal to A L raised to alpha and K raised to beta. This is satisfied by the Euler's theorem. Here, if the total output is distributed on the basis of their respective marginal product, then we can obtain the same level of output, or the total output can be completely vanished off. This is the fourth property. And next property is that the elasticity of substitution of a Cobb-Douglas production function is unity. The elasticity of substitution of this Cobb-Douglas production function is unity. Elasticity of substitution is unity. Elasticity of substitution of this CD function is unity. The elasticity of substitution is somewhat unity. And here this two can be explained by an equation, that is elasticity of substitution eta. Elasticity of substitution, that is eta, is equal to F1 F2 divided by F12 into Q. F12 into Q. This is the formula for finding out the elasticity of substitution. That is eta is equal to F1 F2 divided by F12 into Q. And here F1 represents the differentiated value of this production function with respect to labor, and F2 represents the differentiated value of this production function with respect to capital. And here F12 represents the differentiated value of the production function, and that differentiated value can be conducted in both the ways, like we are differentiating labor, and that differentiated value can be again differentiated with respect to capital. That differentiator, that is if a production function is differentiated with respect to labor, and that differentiated function can again be differentiated with respect to capital, and those by multiplying those function with the level of output, that is Q, it will provide the results like this is equal to 1. This is equal to 1, unity, and thereby we can conduct the same here. F1 is equal to dou Q by dou L. Dou Q by dou L, that is A alpha L raised to alpha minus 1 K raised to beta, and F2 is equal to dou Q by dou K is equal to A L raised to alpha beta K raised to beta minus 1. A L raised to alpha beta K raised to beta minus 1, and F12 we can differentiate this function with respect to capital. That is A alpha L raised to alpha minus 1 beta K raised to beta minus 1. Beta K raised to beta minus 1, and the original production function Q is equal to A L raised to alpha and K raised to beta. A L raised to alpha and K raised to beta, and we can substitute these values in our original equation or original function. That is again equal to, this is equal to F1 F2, means F1 F2 is a alpha L raised to alpha minus 1 K raised to beta and into this then the differentiator value of capital, that is A L raised to alpha beta K raised to beta minus 1. K raised to beta minus 1 beta K raised to beta minus 1, the whole divided by the differentiator value of this one, that is F12. F12 is equal to A alpha L raised to alpha minus 1 beta K raised to beta minus 1. Beta K raised to beta minus 1 into the original function into Q, that is AL raised to alpha and K raised to beta. AL raised to alpha and K raised to beta. AL raised to alpha and K raised to beta. This can be rearranged. That is eta is equal to A alpha L raised to alpha minus 1 K raised to beta. A L raised to alpha beta K raised to beta minus 1, the whole divided by A alpha L raised to alpha minus 1 beta K raised to beta minus 1 A L raised to alpha K raised to beta. A L raised to alpha and K raised to beta, we can cancel the all values together, that is this AL raised to alpha and this one is here can be cancelled out, and this two can be cancelled out. That is here A alpha L raised to alpha minus 1 is there, that is cancelled out, and K raised to beta can be cancelled out like this K raised to beta, and this AL raised to alpha can be cancelled out, this one, and beta K raised to beta minus 1 is equal to this one too. So we can cancel this completely, thereby the value is equal to 1. The value is equal to 1, and thereby says that the elasticity of substitution in this Cobb-Douglas production function is unity. The elasticity of substitution in this Cobb-Douglas production function is unity, that is eta is equal to 1. Eta is equal to 1. Next property is that That is the factor intensity associated with the factor intensity. And here the ratio alpha by beta, the ratio alpha by beta represents the factor intensity. The ratio alpha by beta represents the factor intensity. That is, if alpha by beta is a greater value, if alpha by beta is a greater value, then that production function is represented as a labor intensive production function. If alpha by beta is a higher ratio, if alpha by beta is a higher ratio, then that production function is relatively a labor intensive production function. A labor intensive production function. A labor intensive production function. And if alpha by beta is a lower value, is a lower ratio, of alpha by beta is a higher ratio, then we can say that is a labor intensive production function. And in the case of this alpha by beta is a lower ratio, then this is a capital intensive production function. Capital intensive production function. Capital intensive production function. This is the sixth property. And the last property is that the seventh property is that a strict Cobb-Douglas production function is in the form of that is alpha plus beta is equal to 1. Alpha plus beta is equal to 1, that is constant returns to scale. That is the CRS assumption must be followed by this Cobb-Douglas production function. These are the major properties of this Cobb-Douglas production function. Next one, the importance of Cobb-Douglas production function. Why we are using the Cobb-Douglas production function into the field of economics or in the field of reality. Cobb-Douglas production function. What is the relevance or what is the importance of this Cobb-Douglas production function? And first importance is that it can be used to determine the marginal productivity of labor and capital. It can be used to determine the marginal productivity of labor and the capital because it's already been proved through this properties of this Cobb-Douglas production function. Thereby, we can say that the marginal productivity of labor and the capital in a particular society or a nation, we can find out the marginal productivity of labor and the capital through this Cobb-Douglas production function, and thereby we can determine the wages and the rate of interest through the Cobb-Douglas production function. If we are successful in the case of the determination of this marginal productivity of labor and capital, and it implicitly or it directly or indirectly, we can calculate the rate of interest and the amount of wage availed by the various factors of production through that production function. That is the first importance. And the second importance is that the parameters like alpha and beta of this production function represents the elasticity coefficient. That is the output elasticity coefficient here represented as alpha and beta. Thereby, these elasticity coefficients are helpful in the intersectoral comparison. For the purpose, that is for the purpose of comparison, we can use this output elasticity, that is alpha and beta can be used. Alpha and beta can be used to make an intersectoral comparison because different sectors use different amount of labor and different amount of capital, and thereby here alpha represents the output elasticity of labor and beta represents the output elasticity of capital, and we can make a comparison between the various factors of production's output elasticity in different sectors too. That is the second importance of this Cobb-Douglas production function. And third one is that it is helpful to compute the elasticity values for the intersectoral comparisons too. This can be represented or this can be used to compare the elasticity value of different sectors. The elasticity of different sectors. The elasticity of different sectors. That is the third importance of this Cobb-Douglas production function. And fourth importance is that CD function is widely used in econometrics. That is, this Cobb-Douglas production function is using or this can be used or this is using in the subject of econometrics in a severe way or in an intensive way. That is, everything is proved on the basis of this Cobb-Douglas production function. That is the another importance of this Cobb-Douglas production function. And next one, this production function helps us to study the different laws, that is the returns to scale. Different laws, that is returns to scale. And here alpha plus beta is equal to 1. This is a constant returns to scale case. And if alpha plus beta is greater than 1, which means that there is an increasing returns to scale. There is an increasing returns to scale. Increasing returns to scale. Increasing returns to scale. And if alpha plus beta is less than 1, if alpha plus beta is less than 1, then there existing diminishing returns to scale. Diminishing returns to scale. Diminishing returns to scale will occur in the case of this alpha plus beta, which is less than 1. Thereby, we can say that, or we can calculate the returns to scale with the help of this Cobb-Douglas production function. And next important, this function is used to test the loss of returns and the substitutability of factors. This can be used to study the returns to scale or the loss of returns and the substitutability of the factors of production. That is the last property associated with the Cobb-Douglas production is that is the elasticity of substitution is unity. The elasticity of substitution is unity. Thereby, the substitutability between the various factors of production can also be found out with the help of this Cobb-Douglas production function. That is the another importance. And next topic is the limitation. Next topic is the limitation. Even though we are using this Cobb-Douglas production function in a wide way or wide manner, this Cobb-Douglas production function is not free from its criticism or the limitations too. The first criticism is that the CD function contains only 2 factor inputs. It is consisted with 2 factor inputs. 2 factor inputs, but in reality we are using more than 2 factor inputs. Here the Cobb-Douglas production function is consisted with 2 factor inputs, that is labor and capital. Labor and capital, but in reality the factor inputs are not 2, rather there may be more than 2 factors of production, land and organization. That is another factors of production. That is the first criticism or the limitations of this Cobb-Douglas production function. Second one, the parameter alpha and beta represents the output elasticity of labor and capital. The parameter alpha and beta represents the output elasticity of labor and capital. And here, if this alpha can be used to represent the output elasticity of labor, then we must say that the available labor force is homogeneous in nature or identical in every respect. Identical in every respect, but the existing labor force are not homogeneous. Their productivity and their skills are entirely different from one another. Thereby, the usage of this alpha for representing the output elasticity or the efficiency of labor cannot be a reliable one. That is the criticism. And in the case of beta, that is capital's output elasticity is also entirely a different one, because different capital can become, or different capitals have different productivity. Thereby, the usage of this alpha and beta cannot be reliable in the case of this Cobb-Douglas production function. And third limitation is that in most of the case, the production function represents the constant returns to scale. That is, this Cobb-Douglas production function represented here as a constant returns to scale way. But in reality, we can expect the increasing returns to scale along with the diminishing returns to scale. And that two possibilities are not considered in the case of, or in the formulation of this Cobb-Douglas production function. That Cobb-Douglas production function only considers the CRS assumption, that is constant returns to scale. That is another limitation. And the last limitation is that the function assumes that the technological condition, that is the technology is assumed to be constant. That is the parameter of A. That is the technological parameter, and that technological parameter is assumed to be constant. But in reality, this technology is always changing. The technology is always changing. Thereby, the constancy of this technological parameter cannot be considered, or it may provide a negative results instead of this positive result, which means that the technological parameter cannot be assumed to be constant. It is always changing. Thereby, the result is also entirely different from the results that is provided by the Cobb-Douglas production function.